Hello, welcome to EGN 3613. In this session, we will address the equal payment series. What if I have equal payment that's being paid equal periods like yearly or monthly or weekly, and I would like to find the future amount that will be saved or that will be invested at that time. How could it be calculated? To calculate the payment, we can take each payment A and take it to the future. So we can calculate the number of years, which is in this case, for the first one, it will be A multiplied by 1 plus I all to the minus n minus 1. So that will be the relation or the formula to find the future value f1. Then we take the second one and take it to the future and calculate f2, and so on until we find all the values. Once we find all the values until fn, then I can start adding these values. So this one will be f1 plus f2 all the way to fn, which is in this case fn will equal to A. So adding these values will give me the total future value of these annual or equally period amount payments. So this is how it could be calculated. Now, can we use a formula, or is there a formula that's ready for us to utilize it to calculate the future value, knowing the annuity or the annual payment and the interest rate? Let's see. Adding all these together will lead to one formula, and the formula will be future value f is equal to A, which is the annuity. And when I say annuity here, annuity doesn't mean annual, but annuity is the equal payment, whether it's, like we said, daily, weekly, monthly, or annual. It's called annuity. Annuity means equal payment that's being paid over time. It will the future value will equal to the annuity A multiplied by 1 plus I to the power n minus 1 divided by I. And this is the formula that we can use to calculate the future value. This is the formula that we can use to calculate the future value. As we said before, we can use two methods, or three methods actually. The mathematical method, and this is the mathematical method, and using the tables in the back of the book. This formula will be translated as f equal to A multiplied by f given A with interest I and number of years or number of series, number of equal payments, equal periods n. So f for the future, A for the annuity, I for the interest, and n for the number of equal periods. And this is the second way. And the third way is using Excel sheet. So mathematical, or the tables in the back, or Excel sheets. And this factor, we call this factor, which is the actually let me change the pen or the highlight. I will highlight this, and this is here what we call the compound amount factor. This is the compound amount factor in this series. So we can find the compound amount factor, which is this one, the highlighted. We can find it from the tables in the back. Now let's solve. If we substitute the I with 6%, the N with 5, and the A with 5,000, then we can calculate this amount, and that will be a total of 28,185 and 46 cents. And this is the validation for the calculation, where we have 5,000 every equal period that's been paid, and over 5 years it will be accumulated to 28,185 and 46 cents. This one actually should be a comma, but unfortunately I cannot edit it. For some reason it's not letting me edit that, but this one, let me fix it here, should be a comma. This is a comma and not a period. This is a comma. Now can we find the annuity? Since I know the equation or the formula that's being used to calculate the future value, if I know the annuity. Now what if I have the future value and I would like to calculate the annuity? Using algebra, basic algebra, and moving the terms from one side to another, I can find annuity, and A will equal to F, which is the future value, multiplied by I, the interest rate, divided by 1 plus I, all to the power n minus 1. And that will be the formula to calculate the annuity. We can also use the tables in the back, where A is equal to F multiplied by the factor, this factor, and that is read as A given F with interest I and number of periods N, number of periods N. If we take an example for that, if we have future value of 5,000, N is equal to 5 years, and I is equal to 7%, find A, and we can use the formula, or we can find the factor from the back, and we will find that the annuity A is equal to 869 and 50 cents. 869 and 50 cents. Another example is depositing at the beginning of the year, not at the end of the year, at the beginning of the year. Now remember that we had payment type or deposit type or the interest type, where we said before that with the type it's 0 if it's at the end of the year, or 1 if it's at the beginning of the year. So now I have the payment coming, or we started at the beginning of the year. Beginning of the year means time equal to 0. Time is equal to 0. What will be the calculation in this case, and how can we do it? The solution in this case is to do the initial calculation as we did before, which is, finding the factors, multiplying by the annuity, and that will give you the value. But you have to consider the first year, so you multiply by 1 plus I to the power n, and in this case it's the first year or 1 year, and that will be 1 to the power n, 1, and that will be the value that will be added. So all what we do, we multiply by the interest that will be gained on that amount for the first year, and this is how you calculate the future value. By doing this, if we recalculate, then we will have the future value after 5 years as 29,876 and 59 cents. If we would like to use Excel in this solution or this problem, then all what we need to do is to replace the type from 0 to 1, and if we replace the type from 0 to 1, that means it's at the beginning of the period or beginning of the year, not at the end of the year. You can explore Excel and look at the different financial functions that are available for you, and each one of them will mean something for us, like the future value, present value, and so on. I will give you a short like cheat sheet to look at that will help you in Excel and finding the value for Excel financial functions in Excel. So for example, if we have P is equal to 10,000, I is equal to 8% per year, N is equal to 5 years, find the future value, and you can use the numbers like we did before. You can just enter the numbers and do the calculation, or you can do it with the built-in functions, financial functions that Excel has, such as the future value FV or present value. If you type in a cell that you are looking for the future value, then that will give you the argument, which is the rate, the number of years or periods, the payments, and if I have only present value, I don't have any payments, then I don't have to worry about this. This is the present value, and this is the type that we talked about, which is the beginning of the year or the end of the year. Just putting the numbers that we have, which is P equal to 1000, and that's the present value. N is NPER, number, and that's number of periods, and that's 5. And then the rate is the interest rate, which is 0.08, and then calculate. Then that cell will return for us a value of 14,693 and 28 cents. Another example, if P was 2,000, A is required or wanted for 10 years period of time. I is equal to 7, and I would like to find the annual, the annuity or the equal payment during the 10 years period. In this case, I can find the PMT, which is the payment, the annuity, the payment function, and that's A. The rate at 7%, the number of years or periods is 10, the present value is 2,000, and that will be 284 and 76 cents. That's annual or annuity or equal payments. So A is equal to 284 and 76 cents. So the Excel shortcuts or functions, the financial functions that you need to know: for present value, it's PV; for future value, it's FV; for annuity, A; it's PMT, payments, for n, which is the number of periods. It's n periods, number of periods, n PER, and for the compound interest rate is called just rate. So these are the financial functions that you will see in Excel, and that you need to remember. If you don't remember them, then you have to search under financial and look for these different terms, and that will give you the different function or financial functions that you need. We will also look later, don't worry about it right now, but later we will look at the interest rate, rate of return, IRR, and we will look at the net present value and other functions as we go. So those are the functions that you will find in Excel. The factor, which is I over 1 plus I to the power n minus 1, is called the sinking factor, fund factor, sinking fund factor. So for example, if we were given future value of 100,000, n is equal to 8 years, and I is equal to 7%, find the annuity or the equal payments that need to be paid over the 8 years. In this case, we will apply the formula mathematically, or we can use the book where we can find what's called the sinking factor at the end of the book. Multiplying the sinking factor by 100,000 will give us 9,746 and 78 cents, and that will be our solution using either the formula, the mathematical formula, or using the tables in the back of the book. If you would like to use Excel, then you can use the function that's called PMT, and that will give you or ask you for the following argument: I, the interest, N, number of periods, PV is the present value. I don't have any present value right now, I have future value. FV, future value, is 100,000, and the type is at the end of the year. As you can see here, the payment should be done at the end of the year. That's why I used 0. Applying that in Excel, you should get the same number or the same value, which is 9,746 and 78 cents. So again, you can try to solve it using mathematical solution. You can try to solve it using the tables in the back, or you can use Excel sheet. It's good to practice all three methods and get used to it. Get familiar with calculating the annuity or the future value or the present value using the three different methods. That will make it easy for you to know exactly which method to use and what method is the fastest to use. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.